In this video, we're going to do some exam style questions on integration. This is question number 11. It says, given that the integral from 1 to k of the quantity 3x minus 1 multiplied by x plus 1 dx is equal to 9, find the value of the constant k. Let's go ahead and expand these brackets. So what we've got then is the integral from 1 to k. We're going to have 3x squared plus 3x minus 1x, which is going to be plus 2x. Then we've got negative 1 times by 1, which is negative 1. We're integrating with respect to x, and this is going to be equal to 9. So let's go ahead and integrate. 3x squared, if we integrate, that will give me x cubed. If I integrate 2x, that's x squared. If I integrate negative 1, that's going to give me negative x. We're interested in this from 1 to k, and this will be equal to 9. Substituting in k, we've got now k cubed plus k squared minus k. We're going to subtract from that, substituting in the 1 cubed plus 1 squared minus 1, and that will be equal to 9. So what's that? 2 minus 1, so that's going to give me 1. So we've got now minus 1 on the end, and I'm going to subtract the 9. We can write this as k cubed plus k squared minus k minus 10 is equal to 0. We have a cubic equation in k, and we can look to solve this. In a previous chapter, we've seen how to solve a cubic equation when we have a constant. So all I'm going to do now is let f of k be equal to k cubed plus k squared minus k minus 10. Let's now look at the factors plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Just looking ahead, 1 and negative 1 are not going to be any good. So if we try f of 2, if f of 2 is equal to 0, we can say that k minus 2 is a factor, and it's a solution to the equation. Now k cubed plus k squared minus k minus 10 is equal to 0. So that's going to give me 8 plus 4 minus 2 minus 10. That's 12 minus 12. That's 0. Therefore, we can say k minus 2 is a factor. So a factor, and we can say k equals 2 is a solution. So k equals 2 is a solution. So it's a solution to this equation right here. Now, can we leave it like that and simply say that k is 2? Well, this is a cubic equation. I'm just going to show that k is the only possible solution by using polynomial long division to show that the other two solutions to the cubic are not going to be real numbers. So I would say this is, let's put this in, this is just to show that our only solution is going to be now that k is equal to 2. So setting up the long division, we don't need any placeholders. So k cubed over k is k squared. We multiply down k cubed minus 2k squared. Subtracting away, 0 plus 3k squared minus the k. K's into 3k squared is going to be plus 3k. We multiply down, we're going to get plus 3k squared, then we're going to get minus 6k. Subtracting down 0, we'll get plus 5k, bringing down the negative 10. K's into 5k plus 5, then we're going to get now on here plus 5k minus 10, subtracting away 0 plus 0. Therefore, we can say now that our value of k minus 2 multiplied by the quadratic, which we've just found, which is k squared plus 3k, so plus 3k plus 5 is equal to 0. This right here, if we look now, doing on this particular one, we can say that a is equal to 3, a is equal to 1, b is equal to 3, and c is equal to 5. B squared, 9 minus 4 times by a times by c is going to be less than 0, therefore no real roots. So no real roots to the quadratic, therefore final answer, k will be equal to 2. That is the only real solution. So there we go, k is equal to 2. In the next question, question 12, it says the line y equals 5 meets the curve y equals negative 4x plus x squared for x equal to or less than 0 at the point P, which has coordinates a, b. In part A, we need to find the values of a and b, and in part B, we need to find the area trapped between the curve, the line, and the y-axis to 2 decimal places. Right, let's just draw this up. So what we've got, y is equal to, and I'll just rearrange this, I think, x squared minus 4x. So we can write this as y is equal to x, and then we'll have x minus 4. This is only defined for 0 or less, so we'll have negative values. Now, if we just think about this, what we've got is something that looks like so. So we've got a solution at 4 and a solution at 0 just here. So we're going to have something that looks like that. That's what we have. And we've only got this now defined. So it's not defined. This point is 0, this point is 4, 0. It's only defined for negative values. So to the right of the coordinate axis, what we have, this curve doesn't exist. So that doesn't exist. It's only now this part right here. Let's now consider the line y equals 5. Y equals 5 is a horizontal line like so. So what we've got is this right here. So we've got y is equal to 5. That's this line. So we're going to have a point of intersection. Let's look at that. The point of intersection is going to be just here. And what we need here is ultimately the area trapped between the curve, the line, and the y-axis. So we're going to be looking at this one right here. So let's just find this point right here. So 5, we just set these equal. If y is equal to 5 and y is equal to negative 4x plus x squared, y is equal to now, so 5 is equal to negative 4x plus x squared. So 0 is equal to x squared minus 4x, and then we're going to have minus 5. So what's that going to give me now on here? X will be equal to, and we can just factor this, so what's that going to be? Plus 1, so x plus 1, and then we're going to have x, and then that's going to be minus 5 is equal to 0. So from here, x will be equal to negative 1. X cannot be equal to 5 as x is going to be equal to or less than 0. So this is our point right here. So if we just consider now the coordinates just here, a, b, well, the x-coordinate is negative 1, which we've just found, and the y-coordinate quite clearly is going to be 5, as y is equal to 5. So that's done. A and b is found. What we now need to do is find this area, and let me go ahead and shade this area. So this area right here is what we want, that there. So it's entirely up to me on how I want to do this. What I'm going to do is go ahead now and look at the area of this particular rectangle, and I'm going to subtract away the area trapped under the curve from negative 1 to 0. So splitting this up, let me just go ahead and draw the rectangle. What I've got is a rectangle, and that is the total area, and I'll show how this is going to be split. So what we have is a side length here. This is going to be 1, and this is going to be 5. So this is the total area, and I'll just put that on there. So I'm just looking at this here. What I need to do is find that yellow shaded area. So we can see quite clearly that the area of the entire rectangle is going to be 5. What I'm going to do is put this one on, so this is 5, and I'm going to subtract away from this, and just writing this on, I'm going to subtract, so it's for 5, subtract the integral from negative 1 to 0 of our function, which is going to be now the negative 4x plus x squared. What this is going to do is give me the area trapped under the curve. That's going to give me, and I'll just put this on a different colour so we can see what we're looking at. We're going to be looking now at this area. This is what I'm going to find by taking the integral from negative 1 to 0 of the curve. So the whole thing, the rectangle, take away this bit of area, will give me that. So let's go ahead and do that. So what we're going to have then, that area is going to be, well, that's going to give me negative 2x squared, if I integrate this, plus 1/3 x cubed. And we're interested in this from negative 1 to 0. So that's going to give me 0 plus 0, and we need to subtract away from this. Well, that's going to, if I put in now -1, that's going to be -2. And then if I substitute in here -1, that's going to give me now -1/3. So what's that give me? That's going to give me now a total, -2 subtract 1/3 is going to be -7/3. So that's going to be 7/3. So what that is this green part. I've just used integration to find the area trapped under the curve from -1 to 0. Therefore, total area, what we can do, the area will be equal now to 5 subtract now the 7/3, which is going to give me now a total of 8/3. So that is the area trapped between the curve, this is a curve, the line, and the y-axis, which is just here, as the curve is only defined for values of x equal to or less than 0. So that's another exam style question looking at integration and in particular areas through definite integrals.